Hi guys, I'm gonna make a video for day one, just a few of the questions on here for people who were absent Thursday when we first started this unit. So unit 12 is called series and sequences. A sequence is just a set of numbers in a given order. We can refer to the numbers by a sub 2 is equal to 5. We can also say f of 2 is equal to 5. A sub 5 is equal to 11, or a of 5 is 11. As you can see up here also, so the first term is 3, second is 5, third is 7, fourth is 9, fifth is 11th, sixth is 13th, and 7th is 15th. Remember, you can pause this video at any time, replay it. I'm just going to go through. If a sequence has a pattern where you can obtain the next number by adding the same number, it's called an arithmetic sequence. That number that you keep adding to the previous number is called the common difference. And we have a little formula that we can use, second minus first. It doesn't necessarily have to be second minus first. It just has to be two numbers that are right next to one another, but you have to go backwards in order. So if you look up top here, and I do 11 minus 9, I get 2. If I do 5 minus 3, I get 2. So they just have to be right next to one another. So in this sequence right here, if we use the formula, common difference equals second minus first. The common difference would be 5 minus 3. So the common difference is 2. All right, we're going to have to deal with things like that. We have what's called an explicit formula. The explicit formula is just a rule, an equation, and it allows me to find any term in the sequence. You wouldn't want to sit here and keep adding 2 to find the 100th term. So we can use this formula right here to find any term. So I'll show you how we use it. So a sub 100 equals the first term plus n is 100 minus 1 times the common difference of 2. So a sub 100 equals, just throw the right-hand sign in your calculator, and we get 201. What's really important is if we graph the numbers in our sequence, this is something you want to notice. So the first term is 3, the second term is 5, and if we keep graphing, we notice that it's a linear function. So arithmetic sequences can be related with linear functions. Okay. This formula is on the reference sheet, so you don't have to memorize it, which is great. And we're going to skip this part. I'm just doing a few things. Okay, so if I want you to write a function a sub n, that means that we're going to use the explicit formula for an arithmetic sequence on your reference sheet. And we're just going to replace in. Now this function or explicit formula, rule, model, remember you're going to have two variables in it. So you're always going to have a, let's see which one's the highlighter. You're always going to have your y value and your x value. So those two won't get replaced, but everything else will. So a sub n, oh my goodness, wrong one. A sub n equals the first term plus n minus 1 times the common difference. Now the common difference we didn't find yet, so let's go over here and find the common difference. Remember, it's second minus first. So our common difference is 2.25. So we'll throw that in over here. Okay, so this is my explicit formula. Now you can leave that as the answer, but sometimes they do tell us to express it in simplest form. So if they tell us to express it in simplest form, we need to have an or. So our or would be using a little distributive property backwards right here. So -6 plus 2.25n minus 2.25. I'll move right over here. Combine like terms, and my or could be 2.25n minus 8.25. Sorry guys, I'm trying to get used to this. I'll try and be a little less sloppy as we go along. So this could be an or, but this one here, this is sufficient. This is good, unless it says in simplest form. Or if it's multiple choice and you don't see your answer, then this one could be it. All right, next up. What if they give us the explicit formula? So here they give us the formula, and they want us to find the first three terms. So if they want us to find the first three terms, a sub 1, a sub 2, and a sub 3, you'll just plug the number 1 in for n. So 2 times 1 is 2, plus 10 is 12. If we want to find a sub 2, then we'll plug 2 in for n. So 2 times 2 is 4, plus 10 is 14, and so on. Plug in 3, and we'll get 16. You can write the answer like that, or you can write the answer as a sequence, however you want. All right, let's just look at this a little bit more to do here, and then we'll move on to the next one. Oh yeah, so the last thing to show you here. All right, so what if the terms are not right next to one another? So let's take a look. So it says the fourth term of an arithmetic sequence is 80. So the fourth term is 80. And the 12th term is 32. So the 12th term is 32. And they want me to find the common difference. Well, I can't use second minus first because we don't have the second and the first. We have the 12th and the 4th. But we do have a nice little formula to use, and you should notice something special about it. Here's how we do it. So you're still going to subtract going backwards. Very important you're going backwards. And very important that you subtract the numbers in the sequence. So 32 minus 80 divided by 12 minus 4. So hopefully you notice what this formula looks like. Anybody? Yep, slope. So if we do our slope formula,
they get a challenge card.
we get -6. So there it is. Okay, so you have to look for this. If you don't have terms right next to each other, that's what this guy's doing right here. He's thinking about it. So this is what you would do. Alrighty, let's find the first term of the sequence. So if I want to find the first term in the sequence, look, you can use the explicit formula. The a sub n equals a sub 1 plus n minus 1 times d. Or we could think logically here. If going this way, I keep subtracting 6, then wouldn't I just be adding 6 to go the other direction? And the first term would be 98. Okay, one more thing. So explicit formulas. Now again, they want me to write the explicit formula. So it's on your reference sheet. A sub n equals a sub 1 plus n minus 1 times d. We're just going to replace in our information. So a sub n equals the first term plus n minus 1 times our common difference of -6. Please keep in mind again, when we're writing an explicit formula, a model, an equation, you have to have two variables. Here's your y, and here's your x. Those are not going to get replaced for. All right, so we got a sub n equals 98 plus, we'll do distributed property backwards, so actually we can make that a minus. So minus 6n plus 6. So a sub n equals 104 minus 6n. And there's my rule. Alrighty. So again, this is just a little recap of the first day if you were absent. think, yeah, I think that's pretty good. Okay, we'll finish on this one. So not every sequence not every sequence is arithmetic, and some of them don't have an explicit formula that works every single time. It might be something that you have to notice. So check out this one. The first one is 1. The second one is 4. The third one is 9. And the fourth one is 16. So this is not arithmetic. You can't keep adding the same thing. Notice that here I'm adding 3, here I'm adding 5, here I'm adding 7. So this is not arithmetic because you're not adding the same exact number every time. So you're supposed to look at you're supposed to look at the term and see, what can I do to the term to get this? What can I do to the term to get this? What can I do to the position to get the term? What can you do to the position to get to the term? So some people did notice it the day I taught it. A sub n is equal to n squared. So it's the position squared that would always give you this. So that was just a tougher one that we tried. And we will do more of those as we go. All right, guys, so you should try doing homework. Homework for this was, I think we had Delta Math, and I'll put up a sheet that shows everything, but we had Delta Math day 1, and then I didn't assign this, but you can see this is lots of practice if anybody wants to do it. But I did assign this right here. I assigned page 8. Now, it does say right here, to factor. Really, I should have said solve, fracs, or find the solutions. Okay, all right, good luck. That was my first video. Hopefully that was helpful.